ሰላም ተማሪዎች እንደምን አላችሁ? ዛሬ the extraction of roots የሚሉትን ኤግዛምፕሎች እናያለን። Roots of complex number or extraction of roots of complex number. In this case, suppose not is equal to such forms is the nth root of this non-zero complex number. Z is equals to r e the power of I theta. Here we have a complex number. How can we find the nth root of any complex number? We have such forms. This is the formula that we use this one. How can we obtain this? Since, as we said before, we have the argument we have. That means, if we have such forms, this have the equivalent trigonometric value as we are familiar, whether it is cos theta, whether it is sin theta, whatever, then we can express this theta not at the form of what? And theta not is equal to theta plus 2k pi forms. After obtaining this, we said that our k is equals 0, 1, 2 up to n minus 1. Why? This is because of if we take n is equals k is equals n, which shows n, then it becomes theta over n plus 2n pi over n means what? That is 2 pi. As we are familiar that the trigonometric values of theta over n is equals to theta over n plus 2 pi. We are familiar since this becomes after a complete revolution of that. If this is theta over n, then this theta over n plus 2 pi terminate at the same place after a complete revolution. Complete revolution, we arrive at the same place. So they have the same trigonometric values. Because of this, after n equals to k is equals n and after n, there is a repetition of what we did before. Because of that, we take this z naught is equals r to the power of 1 over n times e to the power of I of theta over n plus 2k pi over n. K runs 0 to n minus 1 should be this. Since if k is equals n and other values, which is n plus 1 and so on, that this complex number repeat itself. Because of this, you have to apply this formula to find the root of a complex number. That means, if say square roots, it has what? The square root. N is equals to, that is 2 square root. That means, the square root of this z is equals 1 over 2. In that case, you have to have 2 roots. This implies you have 2 roots. Similarly, if say cubic roots, that means n is equals 3. In that case, we have what? 3 roots. The same that fourth root, that means n is equals 4 means what? The fourth root of your complex number. In that case, you will have what? 4 roots. And our k runs from 0 to n minus 1. Examples እናያለን. It says that find the square root of the complex number which is given at such forms. Find this, we can observe this complex plane. Z is equal -4 means to have only the real part. Somewhere here is -4. Here is -3, -2, -1. It measures from positive x-axis 180 degree, or which is equals pi rad, we can say. So to find this, the square root of this one, our n from this is equals to, that is 2, since it is a square root, and the modulus of z that we call this is r is equals to absolute value of -4, since we have only the real part, which is equals 4. Or if you want, you can say this is the real square, -4 square plus, we can say 0. Since the imaginary is 0, we get the same result. After obtaining this, we say that we can express the roots are the forms r the power of 1 over n times e the power of I of this theta plus 2k pi over n. N runs from 0, 1 to n minus 1. We say this is k, sorry. This is k runs from this one. Since our n is that is 2, we can say this is the square root of that is 4 is a power of I into our theta principal angle that you have, that is 180 degree or pi rad. We can say here is pi plus 2k pi divided by that is 2, since n is 2, which is equals 2 times e the power of, here is 2k plus 1 times pi over that is 2 here. After this, we can find the roots that have square root. We have two roots. 4 returns 4k is equals to, that is 0. What 5? We have z0 is equals to 2 times e the power of I of, when this k 0, it becomes pi over 2, which is equals 2 times cos of pi over 2 plus I sine of, that is pi over 2. As we are familiar, this is 90 degree. At 90 degree, cos is 0 and sine 1. This is equals to twice. Similarly, for our k is equals to 1, what for? This is z1 is equals to 2 times e the power of I of, here is 2 times 1, that is 2 pi plus pi, it is equals to 3 over 2 pi. Now this is equals to 2 times cos of 3 over 2 pi plus I sine of 3 over 2 pi. Here we have. As we did before, this means 3 over 2 pi means what? That is 270 degree. At this point, in this case, the value of x, that is 0, cos 0 is 0. Cos of 3 over 2 pi, that is 0, but sine is negative 1, which is equals negative 2i. Therefore, the square root of the given complex number are 2i and negative 2i are its roots. Its square root are the square root of complex number, square roots. We have found this one. In other words, if you want, since it is the square root, let's say, or what you can say this, or we can say this is equals, let it be the square root x squared is equals to negative 4 if you want. This implies that this x is a complex number, then this x squared is equals to negative 1 means that is I squared. What implies? This implies that the value of x is equals to plus or minus of the square root of I squared times 4, we can say. Since this I squared we have, this is 4, this is equals to plus or minus, we can take out I, as well as we can take out 4 from, since 4 is perfect square, which is equals twice I. So we can obtain these forms, but we get the result what we did before. The other thing, if this one is the square root of the given complex number z is equals negative 4, means that if we square this 2i as well as negative 2i, you get the value that is negative 4. Let's continue to the next one. Check your source, your square root. Check it if you want. When you check this, since the roots are 2i, if it is 2i, this implies 2i squared is equals to 4i squared, which is equals negative 4. Yes, it is the square root. Similarly, when this is negative 2i, which implies that take negative 2i squared means is equals to 4 times, here is I squared still, which is equal to negative 4. Therefore, yes, the squares of the complex number z is equals to negative 4, we can say. Let us continue to the next one. Find the fourth root of a complex number which is given as such forms. Since it is obtained what? 240 degree means it is obtained at the third quadrant. We have 240. Let's say this one is 240 degree. Then, since if we make this is the principal, if you want, we have to move this way and make this one is what? Negative 120 degree, you can say this. Or, which is equals negative 2 over 3 pi rad. We can express in the rad forms. The next thing that we'll try to find was what is the modulus of this one. The modulus of this z, let it be that is r is equals to, that is 60. Since cos square of 240 degree plus sine square of 240 degree means that is 1. So the modulus is this is equals to 16. After obtaining this, we can find the fourth root says. So our n is equals to what one? Our n is equals, that is 4. And we apply a general forms that we have zk is equals r the power of 1 over 4. Since our n is 4, 1 over 4 times e the power of I of our theta, which is negative 2 over 3 pi plus 2k pi divided by 4. Here we have. We apply this formula. When it comes to this, when simplified, this becomes what? After simplification, this the fourth root of 16, that is 2. This is 2 times e the power of what? This is 2k pi. You can say minus 2 over 3 pi divided by, we can say it is 4. And our k runs from 0 to 4 minus 1, that is 3. For this, k is equals to 0. What? This implies z0 is equals 2 times e the power of, when you make this k 0, it becomes I of negative 2 over 3 pi divided by, you have 4. Our result, which is equals to 2 times e the power of I of what? This is negative pi over 6. Here we have our results now, which is equals to 2 into cos of negative pi over 6 plus minus, you can say plus I of sine negative pi over 6. Here we have. Since cosine is even function, that means cos of pi over 6 and cos of negative pi over 6 have the same value. That means cos of 30 degree is equals to 2 into the square root of 3 over 2. Similarly, sine function is odd function, since sine of negative pi over 6 is equals to negative of sine of pi over 6 or sine 30 degree. This means minus half. So when you take this 1 over 2 common, we cancel this 2 by 2. What remains? The result is equals to root 3 minus I. This is one of its roots. The other one, for k is equals to 1. What for? This is equals to z1 is equals to 2 times e the power of, substitute here is 1. It becomes 2 pi minus 2 over 3. When you take this 3 LCM, this means 6 pi minus 2 pi, that is 4 pi over 3. Here is 4 pi over 3 divided by 4. Other result, which is equals to 2 times e the power of I of, we cancel 4 by 4, what remains? Pi over 3. Which is equals to 2 times cos of pi over 3 plus I sine of, that is pi over 3. Pi over 3 means that is 60 degree. What is cos of pi over 3? That is half. So, which is equals 2 times half. Sine of pi over 3, which is equals root 3 over 2. Since it lies what? Pi over 3 means first quadrant plus I of root 3 over 2. Again, here we can take 1 over 2 common and cancel 2 by 2. What remains? Which is equals to 1 plus root 3 I. Similarly, for k is equals to 2, since k runs 0 to 3, z2 is equals to 2 times e the power of, that means this is 2 times 2 pi, that is 4 pi. 4 pi minus 2 over 3 pi means what? Since it is 4 times 3, 12. 12 minus 2, that is 10 over 3 pi. Divided by, you have the same, that is 4. Which is equals to 2 times e the power of, by 2 this is 5, by 2 this one is 2, it becomes 5 over 6 pi, which is equals to 2 times cos of 5 over 6 pi plus I sine of 5 over 6 pi. Your formula this is 5 over 6 pi means that is almost 150 degree. It lies at the second quadrant. At the second quadrant, the value of cos is negative and the value of sine is positive. In that case, this 150 degree equivalent with supplementary angle, that is 30 degree, and cos of 30 degree, which is equals 2 into negative root 3 over 2, since it lies at the second quadrant, plus sign is positive, this is I, that is half. Again, when you take 1 over 2 common, what form? Which is equals negative root 3 plus I. This is the other root we have. The next and last one for k is equals, that is 3. But for now, this is z3 is equals to 2 times e the power of, substitute here is 3. That means 6 pi minus 2 over 3 pi means what? 6 times 3, that is 18. 18 minus 2 pi, this is equals 16 pi over 3 over, that is 4. Here we cancel this by 4 1, this is by 4, that is 4, which is equals to 2 times e the power of 4 over 3 pi. 4 over 3 pi means what? It is pi plus 1 over 3 pi. This means it lies at the third quadrant. And 2 times cos of 4 over 3 pi plus I sine of 4 over 3 pi. As we are familiar, this is equivalent with 60 degree. Cos of 60 degree, that is what? Half. So this is 2 into negative half, since it lies at the third quadrant. Similarly, our sine function is minus root 3 over 2i. Then what value now? This is equal to, take half is common, so this z3 is equals to negative 1 minus root 3i. Here we obtain this one. This is the value we have. Therefore, what for? Therefore, the roots, that means the fourth root of our complex number z is equal 16 times cos of 240 degree plus I sine of 240 degree are, what are they? Here we obtained, here is root 3 minus I, here we have 1 plus root 3i, here we have negative root 3 plus I, and last one is equals root 3 minus I, 1 root, the other one 1 plus root 3i, the other one is, here is minus root 3 plus I, and last one is roots of the complex number z is equals to 16 times cos of 240 degree plus I sine of 240 degree, we can say. So we can find the other problem or the other roots like this. Let us continue to the next one. It says that find the cubic root of z is equals 8i. In this case, what is cubic root means what? Our n is equals to 3. And if we consider our complex plane map, we show that is 8i means what? There is no real part here, but the imaginary with positive, it is around here, that is 8. So this measures, if you move from positive x-axis to this y-axis, it measures 90 degree. This 90 degree means pi over 2, and our n is this one, and our modulus, what is the modulus? That means we call this r. Modulus of z is equals to r, which is equals absolute value of that is 8. Since it is positive, it is 8. Or if you want, you have to say this is the real square, that is 0 square plus 8 square. We can say give the same result, that is 8. But we asked what? The cubic root of this one. That means our zk is equals to r the power of 1 over 3 times e the power of I of our theta pi over 2 plus 2k pi over, that is 3, since our n is 3. But the result now, this is equals to 8 the power of 1 over 3 means that is 2 times e the power of, you have pi over 2 plus 2k pi divided by, you have what? That is 3. Now let's try to find the roots. K is equals 0, that means for our k, start from 0, what 5? We have the here z naught is equals to 2 times e the power of, when this is k0, it becomes pi over 2 divided by 3, this is pi over 6. But the result now, which is equals 2 into cos of pi over 6 plus I sine of pi over 6. Since this pi over 6 lies at the first quadrant, both cosine and sine function are equal and they are not equal, they are positive. Because of this, this is equals to 2 into cos of pi over 6 means, which is root 3 over 2 plus sine of pi over 6, that is half, so it is I over 2. From this, if we take 1 over 2 common, we cancel 2 by 2 or distribute this one. 2 times root 3 over 2, we cancel 2 by 2, root 3. 2 times I over 2, that means we cancel 2 by 2, then what remains I. Or, if you want, you have to take 1 over 2 common and multiple with 2. The result becomes root 3 plus I. The other one, for k is equals to, let's take 1. This means z1 is equals to 2 times e the power of, take here is 1, it becomes 2 pi plus pi over 2. That means 2 pi plus pi over 2 plus pi over 2 over here is 3, which is equals 2 times e the power of I of, that is 5 pi over 6. Here we have. Let's come to the next, solve this one. This is equals to, our z1 is equals to 2 e the power of 5 over 6 pi means, which is equals 2 into cos of 5 over 6 pi plus I sine of 5 over 6 pi. From this what for? You know, 5 over 6 pi means it lies at the second quadrant and is equals to with 30 degree, since it is 150 degree. So the value for cos is negative. This is cos of 5 over 6 pi is equals to negative root 3 over 2. Plus, it is equals to sine is positive at second quadrant and equivalent with sine of 30 degree, which is equal to half. Again, we can distribute this by 2. This becomes negative root 3 plus I. Next one, for our k is equals to, let's say that is 2, which implies z2 is equals to 2 times e the power of, when insert here, what power? This is equals to 2 times 2, that is 4 pi. This is 4 pi. 4 pi times 2, that is 8 pi plus pi, that is 9 pi over 3, which is equals, it is 4 pi plus pi over 2 divided by what? That is 3, which is equals 2 times e the power of, this becomes 9 pi over 2. This is 9 pi over 2 times, here is 1 over 3. We cancel this by 3, 1 by 3, this is 3, which is equals 2 times e the power of pi over 2. Here we have. For the result, which is equals 2 into cos of pi over 2 plus I sine of pi over 2. You are familiar that this is cos pi over 2, that is 90 degree. In this case, cos is 0. This is 2. Sine pi over 2, that is 1. This becomes 2i. Therefore, the cube root of our complex number are root 3 plus I minus root 3 plus I, and 2i are the cubic roots of z is equals to 8i. We can say this one. Making cube of each of them, you can check whether is equal to 8i or not. Let us continue to the next example. The complex number which is given as such form. As we did before, we'll try to find the modulus, that is I, which is equals to 1 plus root 3i, or that is z, which is equals to 1 plus root 3 square. The result, which is equal to the square root of 4. The square root of 4 means that is 2. Similarly, we can find our principal argument, that is theta is equals tan inverse of the imaginary, that is root 3, the real part, that is 1, is equals to tan inverse of root 3. What is tan inverse of root 3 means? Which is equals to 60 degree. This is equals 60 degree, or we can say here is pi over 3 since it lies at the first quadrant. Since it lies at the first quadrant, here is the real part that is 1, the imaginary part that is root 3, so it lies at the second quadrant. That's why we take this theta is equal 60 degree or pi over 3 rad, that is positive. After obtaining this, we can find the root, that means the square root, and n is equals to, it says square root, that is 2. So zk is equals r the power of 1 over 2 means that is 2 the power of 1 over 2 times e the power of 2k pi plus pi over 3 divided by, here is 2, and k runs from 0 and 1, which is equals what value when k is equal 0? This is 4, k is equal 0, z naught is equals the square root of 2 into I is the power of what? I of, when this is 0, it becomes pi over 6. This is equals the square root of 2 times cos of pi over 6 plus I sine of pi over 6. Then, which is equals the square root of 2 times cos of pi over 6 means equivalent, that is cos of 30 degree. This is equals to root 3 over 2 plus, when come to I sine of pi over 6, that means sine 30 degree, which is equal to half. So the result becomes, if we take 1 over 2 common, which is root 2 over 2, is root 2 over 2 times root 3 plus I. This is one of the root. Similarly, the other one, for k is equals to, that is 1, which is equals to z1 is equals the square root of 2 times e the power of, insert here is 1. It becomes 2 pi plus pi over 3. This is 6 pi plus pi, that is 7 pi over 3. 7 pi over 3 divided by 2, that is over 6, which is equals root 2 into cos of 7 pi over 6 plus I sine of 7 over 6. Since this 7 over 6 pi means what? It lies at the third quadrant. In that case, both sine and cosine are negative, which is equals the square root of 2 into equivalent to 30 degree. Cos of 7 pi over 6 is, that is negative root 3 over 2. Similarly, sine is negative, here is minus half. What the result? If we take again half is common, or negative half is common, which is equals negative root 2 over 2 into root 3 plus I. Therefore, the roots are the square root of this here and this one. These are the square root of our complex number. Z is equals to 1 plus root 3 I. Let us see the other examples with similar. Find the square root, it says, of the complex number which is given as such follows. To find this, as we did before, right, you'll try to find what? The modulus or R of this complex number, which is equals the square root of real square, that is negative 2 square, plus negative 2 root 3 square under square root. When come to here, which is equals the square root of, here is 4 plus 12, which is equals the square root of 16 is equals to, that is 4. Our modulus is 4. After obtaining this, we are familiar that it lies what? At the third quadrant. At the third quadrant, that is both are negative, and our theta is equals to tan inverse of the imaginary, that is negative 2 root 3, divided by the real part, that is negative 2, which is equals tan inverse of, that is root 3, which is equals what we did before. But tan inverse of this root 3, since it is positive, we can say tan is positive at the first and third quadrant. But our component, that means x and y component, or the real, the imaginary part, lies at the third quadrant. We take This is what? Pi plus some values. And tan inverse of root 3 is equal to 60 degree. So we add 60 degree to 180 degree. This is equals 240 degree, or which is equals 4 over 3 pi r. But we can't take this as a principle. The principle becomes is equals to negative 120 degree, or negative what? It becomes here is 2 pi, negative 2 pi over 3, negative 2 pi over 3 r. So this is the principle that we want to take, this one. After obtaining this principle and our n is 2, again n is equals to, we can perform or find the square root of our complex number using the forms, that is zdk is equals the square root of 4 times e the power of I of 2k pi minus 2 over 3 pi over, that is 2, which is equal the square root of 4, that is 2, is the power of 2k pi minus 2 over 3 pi divided by 2. We apply this 4. And k runs, k can be, that is 0 and 1 since it is square root. So for our k is equals to, that is 0, the value that is z naught is equals to 2 times e the power of, this make it 0, it becomes negative over 3 pi over 2, this is equals to negative pi over 3, which lies at fourth quadrant. Since negative pi over 3 is, that is negative 60 degree, it lies at the fourth quadrant, which is equals 2 into cos of negative pi over 3 plus I sine of negative pi over 3. Right. When it comes to here, this is equivalent to cos of 60 degrees. Since negative pi over 3, it lies at the fourth quadrant. Cosine is even function, it has the same value, so which is equal to 2 into, which is half. But sine is odd function, which is equals sine of negative 60 degree is equals to minus root 3 over 2i. For the result, we can take half common, which is equals 1 minus root 3i. This is one of the roots. The other one, 4k is equals to, that is 1. z1 is equals 2 is the power of 2 pi minus 2 over 3 pi. That means it becomes 6 pi minus 2 pi, that is 4 pi. It is 4 over 3 pi over, that is 2, which is equals to z1 is equals 2 into e the power of, we cancel this one, 2 by 2, what remains? 2 over 3 pi. This is 2 over 3 pi, which is equals 2 into cos of 2 over 3 pi plus I sine of 2 over 3 pi. The result now, which is equals 2 into cos of 2 over 3 pi means it is 120 degree. Since it lies at the second quadrant, in that case cosine is negative, and equivalent to is 60 degree, which is negative half. Again, when you take half common, which is equals to negative 1 plus root 3. Therefore, the roots or the square root of our complex number are 1 minus root 3 I and minus 1 plus root 3 I. Come to the next one. It says find the cubic root of complex number z is equals minus I. Similarly, we ask it what? Cube root. So our n, that is 3. The modulus for this is equals r. We say this is 1. We take the absolute value for this one. Or, as I told you before, we can find that as square root of 0 square, the real part is 0, plus the imaginary minus 1 square. You get that same result, that is 1. And when we consider our xy plane, that means the complex plane, this is negative I means what? It lies what? At the third quadrant. We move like this. This is negative 1. So, to make the principle, we move what? Clockwise direction to arrive this here. this is equals to our theta. The principal argument here is negative pi over 2. Since if we move in this way, that is 3 over 2 pi cannot be principal argument since it is greater than pi. After obtaining this, what for? Our cubic root, that is zk, is equals the cube root of 1, that is 1. So it becomes e the power of I of 2k pi minus pi over 2 over, that is 3, since it is cubic root. And k runs 0, it can be 1 and it can be 2. From this, for the value k is equal to 0, what for? Z0 is equals to e the power of I of, since this k is 0, it becomes negative pi over 2 over 3, means here is negative pi over 6. For the result, which is equals to cos of negative pi over 6 plus I sine of negative pi over 6. As we are familiar, you know, cosine is even function. This is cos of pi over 6, equivalent with cos of pi over 6 is equals to root 3 over 2. Plus, in case of sine function, since sine is odd function, this becomes minus of half. The result is this one. Or, if you want, you have to take 1 over 2 common and express as forms root 3 minus I. This is the one root of our complex number, that's one. The next one, what form? That means 4k is equals to 1. What form? Here is z1 is equals to e the power of 2k pi. That means it becomes 2 times 1 times pi, that is 2 pi. 2 pi minus pi over 2 over, that is 3, yes, since it is a cubic root over 3, which is equals e the power of I of, take this is 4 pi minus pi, 3 pi over 2 divided by 3, it becomes pi over 2, which is equals to cos of pi over 2 plus I sine of pi over 2. Since pi over 2 is like this one at second quadrantile angle, that means cos of pi over 2, that is 0, sine pi over 2 is equals to, that is 1. So it is I. Similarly, for k is equals to 2, z2 is equals to e the power of I of 2 times 2, that is 4 pi. Here is 4 pi minus pi over 2 divided by, that is 3. One result, which is equals e the power of I of 8 pi minus pi, that's 7 pi over 2 divided by 3. Here is 7 over 6 pi. One result, which is equals cos of 7 over 6 pi plus I sine of 7 over 6 pi. You know, cos of 7 over 6 pi means it lies at the third quadrant. In that case, we have cos is negative. This is negative root 3 over 2. Similarly, sine also negative. Here is minus half. If you want, you have to express this as forms. Take negative half common and it becomes root 3 plus I forms. So this is the other root. This is one root, this is the other root, and the first root we have is this one. Therefore, we obtain the 3 roots of the complex number z is equals to negative I. As we did before, therefore, I negative 1 over 2 times, here is root 3 plus I and 1 over 2 root 3 minus I are the roots, the cubic roots of our complex number, that is z is equals minus I. You can check this by cubing. Take the cube of these roots you can check whether it is equals to negative I or not. Check it. When you come to the last one, it says that find the fourth root of this z is equals to 16. From this, if it says fourth root, our n is equals 4. What about the modulus? That is z is equals r is equals to, that is 16. And what about our theta? The principal argument we have, if we consider this is the complex plane, it says it is 60. 60 means it lies at the positive x-axis. This shows that our theta is equals 0 degree. So after obtaining this, we can express zdk using the forms, the fourth root of, that is our modulus 16 times e the power of I of, here is 0 plus 2k pi over that is 4, since our n is 4, which is equals 2 times e the power of I of, we cancel 0 plus 2k pi over 4, that is by 2, 1 by 2, this is 2, so it is k pi over 2. After obtaining this, k must run 0 to 2, 3, we can say, or 0, 1, then 2, then 3, we can say this. After obtaining this, we can find the value for the roots for k start from 0, which implies z0 is equals 2 times e the power of I of 0, I0, which is equals 2 times e the power of 0 means 1, so this is equals to. Second one for k is equals 1. This is z1 is equals to 2 times e the power of, insert 1, this is I of pi over 2, which is equals 2 into cos of pi over 2 plus I sine of pi over 2. The result becomes cos of pi over 2 means that since it is 90 degree, it is 0, sine pi over 2, that is 1, 1 times I times 2, which is equals 2i. We obtain this one. Let's come for k that equals to, next one for k is equals, that is 2, which implies z2 is equals to 2 times e the power of I of, insert 2 there, 2 over 2 means 1, so it becomes 2 pi over 2, this is pi, which is equals 2 into cos of pi plus I sine of pi. Cos of pi, that is negative 1, sine of pi, that is 0, so it becomes negative 2. Last one for k is equals to, that is 3, which implies z3 is equals 2 times e the power of 3 over 2 pi I, we can say this, which is equals 2 into cos of 3 over 2 pi plus I sine of 3 over 2 pi right. Then the result becomes, this is 2 into cos of 3 over 2 pi, that is 0, by sine 3 over 2 pi, that is negative 1, so it is negative I. The result becomes negative 2i. Now we complete all the options that we have. K runs from 0 to 3. Therefore, 2i, negative 2, and negative 2i are the fourth root of the complex number z is equals to 16. 1, 6. This is 16. We can find such forms. Or if you want, you can say that here we have 2 plus minus 2 as well as 2i minus 2i. That means our roots are plus or minus 2 and plus or minus 2i are the roots. We can express in different forms whatever the case. So we can find the roots of any complex number, or we can extract the roots of any complex number using such forms. ስለዚህ የመጀመሪያው ነገር ኤክስትራክት ወይም ደግሞ ሩትስ ኦፍ ኮምፕሌክስ ነምበር ለማግኘት ሞዱለስ እናገኛለን and principal angle እናገኛለን። ያንን ካገኘን በኋላ we use the form that we derived before, that is zk is equals to r the power of 1 over n times e the power of I of theta plus 2k pi over n forms 4k runs from 0 to n minus 1 and theta is the principal argument that we have. ስለዚህ ይህን ፎርሙላ አፕላይ በማድረግ ምን እናደርጋለን ማለት ነው ሩቶቹን እናገኛለን። ነገር ግን as I told you before, this k runs from n minus 1 ድረስ ነው። n minus 1 greater than n or equal n ሆነ ማለት ምን እያደረገ ይመጣል? የሰራናቸውን ሩቶች ምን ያደርጋል ማለት ነው ሪፒት እያደረገ ነው የሚመጣው። በዛ አይነት መንገድ የተለያዩ ጥያቄዎችን መስራት ትችላላችሁ። if you have any question regarding this በኮሜንት ላይ አስቀምጡልን። ቻናሉን ሼር፣ ላይክ፣ ሰብስክራይብ ማድረጋችሁን አትርሱ። መልካም ጊዜ እንዲሆንላችሁ እመኛለሁ። ባይ ባይ።